As we go on to topic 2 of chapter 8, we go into what is called the quadratic formula. Now, we know that the standard form of the quadratic formula or equation is ax squared plus bx plus c equals 0. Now, if we solve this equation for the letter x using completing the square, and actually this is done. I'm going to go to the textbook for a moment, right there. Solving using the quadratic formula. There's what I have there. And if you take the c term, bring it over to the other side, and then looking at our textbook, it takes you step by step, plus it gives you, over here on the right, I'm cutting some of it off, but in your textbook it goes through the whole thing. Eventually you end up with a value for x. X is this. And you have solved the quadratic equation in general form for the letter x. So if you put something in the quadratic equation standard form, you can then find what the letters A, which are used there, B, which is used there, and then finally a C, which is used there. We can use this as a general way of solving quadratic equations. So let's get back to where we were, right here. Okay, now what again is the quadratic formula? And let me write these two things down because this is important. So ax squared plus bx plus c equals 0. This is the standard form of the quadratic equation. Now this is what is used, again, by completing the square to solve for the letter x. Now when you do it, you get this. X equals negative b plus or minus the square root of b squared minus 4ac. And now all of this is over 2a. And you might say, what are these letters for? Well, these letters are the a value, which is the coefficient of x squared, the b value, which is the coefficient of x, and then whatever constant you have. This is your a, b, and c. Now to get the proper value of this, it has to be in standard form. You can't have a c on this side and use that value, because on this side it would have the opposite sign of what it has on this side. So this is in standard form, well, except for the 4. So we have to put it in standard form. It's going to be 3x squared plus 11x. Transpose the 4, negative 4 equals 0. Now it's in standard form, and let's identify our letters. Our A is 3. Our B is a positive 11. And our C is a negative 4. So while we have this one, let's substitute this into our quadratic formula. So it's going to be x equals, now b is a positive 12, but in the formula it's the opposite of a positive, which makes it a negative 11. That's our B value. Remember, the B is a positive 11. The negative sign is part of the formula, plus or minus. Now, B squared, we can put it right under our radical sign as, instead of 11 squared, let's put it 121. And then minus 4 is in the formula. A over here is 3. And C is a negative 4. And that's all going to be over 2A. And 2A is 2 times 3 is 6. So let me work that for you. So I don't lose anybody. I have just put this in there. And now I'm going to multiply a negative times a negative, get a positive 16 times 3 is a positive 48 here. That when I add this together, I get under my radical a 169, which is a perfect square. The square root of 169 is 13. So this is what I have. 11 plus 13 is going to give me a 2 over 6, which is 1/3. And then I have a negative 11 and a negative 13. That's going to give me a negative 24 over 6, which gives me a negative 4. So my answers then, using the quadratic formula to solve this quadratic equation, once we put it into standard form, identifying our A, B, and C value, plugging it into the quadratic formula, I get my solutions are 1/3 and negative 4. Now an interesting thing, when you see it come out like this can actually be factored. So let's just factor this to double check it. So this is going to be 3x and x, 4 and 1. This is going to be a positive, and this will be a negative. So equal each of these to 0. This is x is a 1/3, and here x is a negative 4. Now, this wouldn't be a good example to use completing the square, but it is factorable. That was one way to solve the quadratic equation, and we use the quadratic formula. Okay, we're going to clear this up and let's take a look at this next one. Now here, again, you don't know what your A, B, and C are, so we have to first clear the parentheses. So we go x squared plus 3x equals 6x minus 9. So x squared, 3x, 6x minus 9. Then we put it in standard form. X squared, we're going to bring this over. That becomes a negative 3x, and this becomes a positive 9. And that equals 0. So what's the first thing we do? We identify our A term, which will be a 1. Our B term now is a negative 3, and our C term is a 9. So we then put this into the quadratic formula. X equals negative B, so if it's the opposite of a negative 3, makes this a positive 3. Plus or minus, we're going to square that now. We square negative 3, this always becomes a positive, minus 4a, which is 1, 4ac. Now c is a positive 9. And this is all over 1 times a, or 2 times a, I should say, which is a 2. Or 2 times a is 1. All right, let's figure this out. And as I pause the tape, I'm checking my work because, again, any little error with a sign, you won't get the right answer. It's a little tedious, but this works for any quadratic equation, as long as you identify your A, B, and C term properly. So we have under the radical now a negative. So let's work with that a little bit. We have a an I is coming out of there. And then we have the square root of 9 times the square root of 3. What is the square root of 9? Well, that's going to be 3i, the square root of 3. That's from chapter 7. So this is going to become x equals 3 plus or minus 3i, the square root of 3. And each of these will be over 2. Now, they don't write the answer this way, but actually that is the proper form, a plus bi, to write complex numbers. Now, they have it all over 2 as an answer down below. Maybe MathLab will accept it that way. I know in chapter 7 they wouldn't. Okay, so again, the key to this, put it in standard form, find your A, B, and C, carefully put it into the quadratic formula, and you get your answers. All right, let's raise it up a little bit, although we need that room in there. Although we have some room down below, too. All right, well, we'll keep that in mind. So notice that in letter C, they are asking us for this in function form as it equals 0. So this then is already in standard form, equaling it to 0. So what is A? A will be a 4. B, your B term is a negative 5. And your C term is a negative 2. So let's put it in the quadratic formula. X equals a negative B. Well, since it's negative, it then becomes a positive 5 plus or minus the square root of b squared is 25 minus 4a, a is 4, and c, I gotta remember that's a negative 2. That would have really messed me up if I didn't put the negative there. And then that's all going to be over 2a, which makes it an 8. Okay, so we put it in our quadratic formula. This is a negative times a negative makes this a positive 32. 32 and 25 give me a 57. And we can't, there's no perfect square factors in there. So this is basically our answer. That one was a little bit easy. All right, let's go on to letter D. Now, as we look at letter D, again, it's this function and this function, and they equal each other. So that's all I did. And we see we have a quadratic equation, but we have fractions. So what would we do in chapter 6 if we have a radical equation like this, or a rational equation? We're going to multiply everything by the lowest common denominator, which is x squared. So here, nothing cancels out, and we get 4x squared. Here the x cancels out, one of them, and we get a plus 3x. Now I could have put that on this side. On this side, this would just become a negative, so let's just change that. And then it's on this side now. So the x squares cancel out, and we get a negative 5. So even though it looked a little daunting in the beginning, we now have it in standard form of the quadratic equation. This on the other side became a negative, and we have it in standard form. So what is our A term? A 4. Our B term? A 3. Our C term? A negative 5. So now we put it in the quadratic formula. Negative b is going to be a negative 3 plus or minus the square root. Now, b squared is 9 minus 4a, which is 4, c, which is a negative 5, all over 2 times a, which is 8. So I used my calculator and I checked my work. A negative times a negative made this a positive. This is going to be 20 times 4 is 80, plus 9 is 89. And again, there are no perfect squares in there, so we just leave it that way. And that's our answer. Okay, now on this next one, they're asking us to use a calculator to approximate to 3 decimal places. Now, actually, I have a calculator that solves the quadratic formula. I can just put in there my A term, my B term, and my C term. I hit enter, and it gives me an answer. But I'm assuming what they want you here is to put it in this way. X equals a negative B plus the square root of B squared, which is 64, minus 4a, which is 1, and c, which is 10, all over 2. Then you're going to put the stuff in there again, and you go, this time, negative b minus, well, b is our 8 here, so we can put the 8 in there, negative 8 minus what's under the radical sign, all divided by 2. And you'll get some answers, and actually the approximation is down below. And here, the very same thing. They want you to put it in the quadratic formula, one with a plus in front of the radical sign, one with a negative. Now don't forget, all of this is going to be in a parenthesis divided by 2, and then all of this in a parenthesis divided by 2. And I would also put this in a parenthesis, or get an answer, put this, add it to 8, put that in a parenthesis, divide by 2. Remember, your calculator only does what it thinks it's supposed to do according to math theory. If you want it to do something, but you actually punched in for it to do something else, it will do something else. But you can check your answers. They are down below. At least these were set up nicely. There is your A, there is your B, and there is your C. And as I mentioned, the answers are right there. So if you're not getting these, this is where you're going to need help in your math lab. Okay, just under 20 minutes.